Hello, we are from St. Aloysius High School, class of 2017. We are going to present to you an experiment of how to measure electric currents using coil guns. My name is Christina Amanda.
My name is Grisella Aglia.
My name is Cenia.
My name is Silviana and let's
Get
Go
started!
First of all, the things you will need will be a laptop. Any kind will do as long as it's functional. Ruler, preferably 30 cm or longer. A variety of coils. A long wire. A piece of cardboard and a coil gun. And that's all you'll need.
So for this experiment, we use coils with 200 loops, 250 loops, 300 loops, and also 350 loops. And also use coils like this one, which can launch coins upward. For the laptop, don't forget to install Audacity in it, because we will use it to collect data. This is the coil gun that we use. The lamp lights up when the coils are charging and turns off when it's full. This button is to charge, and this one is to launch the projectile. And this is a flyback diode, the cable, the capacitor, the switch, and the coil. We also used a multimeter and we found out that it has 6.26 volts and 2 ohms. And this is a cable that we use to connect the laptop to the coil gun. Now let's get counting. And this is a set that we use for calibration. We use a coil gun, a 6-volt power supply, and a 2 ohm resistor.
So now I will explain about the calibration. First, we measure the resistance of the resistor with multimeter. We get a number of 2 ohm. After that, we set the power supply with voltage of 6 volts and measured using a multimeter. It reached the voltage of approximately 5.9 volts. After that, we put an alligator clamp to the coil gun, resistor, and power supply for tying it into a series. After you connect to your laptop with a cable, we open the Audacity program and record the resulting pulse. Now I will tell you how to calculate the current and calibration of the pulse. We use MATLAB programs to do that. First, we need to make sure the file is in this box. We name it kalibrasi kedua. After that, we input the formula and we get the amplitude of the pulse. This is the picture of the pulse. And now this is how we got the pulse max amplitude. Because of the amplitude of all the pulse is almost the same, we pretend that the mean of the amplitude is the max amplitude of the pulse. The maximum of amplitude of the pulse is 0.4393. We already know that the maximum amplitude of the coil is 0.4393. The angular velocity that we use in accordance with Formula 2PF, where the frequency of Pilot Indonesia is 50 Hz. So we get the angular velocity is 2 multiplied by 22 divided by 7 and multiplied by 50. The velocity that we get from the measurement results is 6.26 volts. The resistor we use once measured with multimeter shows the number 2 ohm. The current is obtained from Ohm's law, where the current is the voltage divided by the resistance. So we get the current of the amperage is 3.13 ampere. The maximum amplitude of Y is equal to the angular velocity multiplied by the current multiplied by the calibration constants. So we get the calibration constant of 0.000444. In the time of calibration, we use a microphone level 100. Since the time of the experiment we use a microphone level of 25, then the result of the calibration. So we get the calibration constant is 0.000111.
Now I will explain about this experiment. First, we install the multimeter to the coil gun using alligator clamp. Make sure that the part of the black multimeter is connected to the negative, while the red one to the positive. Set a multimeter to the voltmeter. After that, the coil gun is connected to laptop with cables at the microphone. Then the iron stem is inserted into the coil to a certain extent. Then coil gun in charge. When in charge, the lights will on until it finally dim and off. When a voltage more than charge is released and wait until 400 volt. The shot is done when the multimeter use Audacity to capture the pulse. Don't forget to change the microphone level to 25. This is a pulse that results from the shoot.
Now I'm going to calculate the flow. First, we need to open the file from Audacity. The file must be exported by wave. After that, we will use MATLAB to calculate the current. First, make sure the file is there in the box. That's the file. After that, enter the formula. It is the amplitude of the pulse. By entering the formula, plot Y is the picture of an enlarged pulse. We need to calculate area under the x-axis. We have to zoom in the picture until it finds the number that is approaching the line. The number we get is 5855. Do it to the other end of the line. Make sure that the limit calculated is only up to 0. The number we get is 12385. After that, insert it into the formula to find out the amplitude of the area below x-axis. After that, put in the following formula. The sum of amplitude divided by the frequency divided by the constant calibration is the current. We got the number 44100 from the frequency that is used in Audacity. So, the current that we get is 363.7 ampere.
This is the result of our current measuring. The coil that has the largest current is the coil with 350 loops. The second one is the 300 loops coil. The third one is the 200 loops coil, and the fourth one is 250 loops coil. It's a set of tools that we use to calculate the inductance of the coils. We have the coil, the power supply, and we use 4 different frequencies: 1000, 5000, 7000, and 10,000 Hz. We also use a 2 ohm resistor. Then we calculate the voltage of each component using a multimeter. Now I will describe how to calculate the inductance. This is the component that we use when calculating the inductance. There is an audio generator, multimeter, and circuit boards to make electricity.
These components are installed on the board as shown in the video. Then, the set is connected to the audio generator. Frequencies used in this experiment are 1000, 5000, 7000, and 10,000 Hz. First, the frequency set to 1000 Hz. The voltage of each component is measured and recorded. We calculate the voltage of resistors, coils, and the total voltage. After that, the frequency is changed, and the voltage is measured.
This is the result of the inductance. The current we got from Ohm's law. Since the time of the experiment we used a resistor that has a resistance 100 ohms, then the current we get is the resistor voltage divided by the resistance of the resistor. We get the inductive reactance with inductors with voltage divided by the current. Inductance is obtained by inductive reactance divided by the angular velocity. The angular velocity formula is 2 multiplied by the frequency multiplied by P. It can be seen that the coil that has a 200 loop is the smallest inductance. The largest is 250. From small to large, it sorts from 200, 300, 350, and 250.
This is the voltage result that we got from counting the inductance of the coil.